Here we have a log equation that says log base 8 of x plus 3 equals 1 minus log base 8 of x plus 1. To begin, we'll get the logs on the same side. This means we'll take the negative log base 8 of x plus 1 and move it to the left side. The one that comes in front of it we'll leave where it is. Therefore, on the left, we will now have log base 8 of x plus 3, and now plus log base 8 of x plus 1. On the right, we'll still have the 1. Now that we have both log terms together on the same side, we can combine them into one bigger log. When we combine them, we'll begin by writing log base 8 and then a larger parentheses. The x plus 3 will go into a parentheses inside that bigger log, and the x plus 1 will go there as well. On the right, we'll still have equals 1. Now, since we have a log base 8, we can use a base 8 exponential to cancel it. Therefore, we will write an 8 on both the left and the right. We'll put this big log term as the exponent to that 8 on the left. We now have log base 8 of x plus 3 times x plus 1. And on the right, we'll have 8 raised to the first power. Since the base 8 and the log base 8 are inverse functions, we may cancel them. The exponent that has x plus 3 times x plus 1 will stay. So on the left, we now have x plus 3 times x plus 1 is equal to 8 to the first power. You may be able to see that we have a second power equation. Since this equation is second power, we're now going to have to get everything onto the left side to solve it. With our new second power equation, we'll begin by using the FOIL method to multiply the x plus 3 times the x plus 1. When we multiply together the x plus 3 times the x plus 1, we'll begin by taking x times x for x squared, x times 1 for 1x, 3 times x for 3x, and then 3 times 1 for 3. If we combine the like terms in the middle, 1x plus 3x makes 4x. Now we have x squared plus 4x plus 3. This is equal to 8 to the first power, or just 8. Then we're going to try to get everything onto the right side. This means we'll subtract the 8 from the right and the left. This will give us 0 on the right. On the left, we now have x squared plus 4x minus 5. This will be our new second power equation. And now we factor it to try to get the value of x. Our constant in this second power equation is negative 5. Therefore, we'll try to find two numbers that multiply to negative 5. If we take negative 5 and positive 1 and multiply, we would get negative 5. If we add, though, negative 5 plus 1 gives negative 4. It's the right number, but not the right sign because we want positive 4. Therefore, we'll use positive 5 and negative 1 to get that positive 4. Therefore, when we factor, we end up with x plus 5, x minus 1 is equal to 0. If we solve the first piece, we'll end up with x equals negative 5. If we solve the other piece, we'll end up with x equals 1. Now that we have two solutions, we'll check to make sure that neither one of them violate the domain rules for the log. We'll take our solution of x equals negative 5 and try plugging it into the log terms. If we place the negative 5 in the first log term, we'll have negative 5 plus 3. If we do the same to the other, we'll have negative 5 plus 1. If we combine these numbers, we'll end up with negative 5 plus 3 gives negative 2. We can actually stop right here, because the log rule says that the inside of the log must be greater than 0. In fact, since we have two log terms, they both have to be greater than 0. So if either log term returns an answer that's not greater than 0, we can stop and say that that x value is not a true solution. This will give us a false answer. This means x equals negative 5 is not a true answer. Now let's also try x equals 1. In our first log term, we'll have 1 plus 3, and then in our other log term, we'll have 1 plus 1. 1 plus 3 is greater than 0 because that's 4, and 1 plus 1 is 2. That's still greater than 0. This means that this x equals 1 is a true answer, and that will be our only true solution to this log equation. Thank you for watching. We'll see you again soon.